We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Myself, Dr. Dikshitkumar, Associate Professor from SHREE NARANJIBHAI LALBHAI PATEL College of Pharmacy, Umrak. Good morning to all. Today I am going to deliver a lecture on isolation, identification and analysis of glycyrrhetinic acid and rutin. In my previous lecture, I have discussed the isolation, identification, analysis of senosides and diazonin. In that lecture, I have discussed regarding the what is isolation, what is identification, and what is the analysis. So there is no need to explain regarding the terminology. You can refer the previous lecture for that. Today I am going to learn isolation, identification, and analysis of glycyrrhetinic acid and rutin. What is glycyrrhetinic acid? So glycyrrhetinic acid is the chemical constituent which is derived from the Glycyrrha glabra. The biological source for the glycyrrhetinic acid is obtained from the dried, unpeeled roots and stolons of Glycyrrha glabra belonging to the family Leguminosae. Glycyrrhetinic acid itself, it is a pentacyclic triterpenoid aglycone which is derived from the glycyrrha. It is mainly used as an anti-ulcer. Glycyrrha is a such type of drug which is very useful in herbal formulations as a sweetening agent. The sweetening agent which is present into the glycyrrha, it is a glycyrrhizin, and glycyrrhizin is responsible for sweet taste of the glycyrrha. Now we move on the isolation of glycyrrhetinic acid. So for the isolation, first we have to collect the dried, unpeeled roots and stolons of the glycyrrha. We have to properly dry it, then make a coarse powder of the roots and rhizomes. Then this coarse powder is extracted with chloroform for a particular period of time. After the completion of extraction, we have to filter the chloroform extract, discard the filtrate and collect the mark or residue. Here you have to remember, we have to use the mark or residue. Do not use the filtrate. In many of the extraction, we are collecting the filtrate, concentrate the filtrate and further do the procedure on this filtrate. But here we have to collect the mark or the residue, extract the mark with 0.5 molar sulfuric acid for a few hours. After treating with the sulfuric acid, filter the acidic layer and extract the filtrate with 3 portions of the chloroform, and combine all the portion of the chloroform and then distill of the chloroform extract or concentrate the chloroform extract to produce a dry residue of glycyrrhetinic acid. White crystalline powder of glycyrrhetinic acid is obtained. So here we are using a chloroform as a main organic solvent for the isolation of the glycyrrhetinic acid from the Glycyrrha glabra powder. Now we move on the identification. How to identify the glycyrrhetinic acids? So glycyrrhetinic acid is a pentacyclic triterpenoids. So as a pentacyclic triterpenoid, it will gives the chemical taste like a Lieberman or Lieberman-Bouchard test. In the Lieberman-Bouchard test, like take 2 ml of drug solution, 2 ml of acetic anhydride, boil and add 0.5 ml sulfuric acid. It gives a blue color. Blue color indicates the presence of glycyrrhetinic acids. Now analysis by the thin layer chromatography. In the thin layer chromatography, you all know the stationary phase should be a silica gel G. Mobile phase is toluene, ethyl acetate, glacial acetic acid. The ratio of all solvent 12.5 is to 7.5 is to 0.5. Sample preparation, generally whenever we are doing the TLC, we are preparing the solution 1 milligram per ml in a methanol, but here we are preparing a 1 milligram per ml of glycyrrhetinic acid in the solution of methanol is to chloroform. Both are 1 is to 1. Detecting agent is a 1% vanillin sulfuric acid and heat for 10 minutes at 1100 degrees centigrade. Then here we are using a reference drug or standard drug as a glycyrrhetinic acid. So what we have to do? We have to make one solution of the standard drug, another solution of the sample. Then we have to put both the spots on the TLC plate. One is a standard, one is our extract. Then we have to compare the spot of the standard and sample. Both spots are at same RF. Then we can say that our extraction is good, or our extract contain a glycyrrhetinic acid, or whatever the spot we got is a glycyrrhetinic acid. We get the RF value should be a 0.41 and the spot color should be a purplish. So by the thin layer chromatography we can analyze our glycyrrhetinic acids by comparing with the standard. So it is a regarding the glycyrrhetinic acid. Another estimation also we can go for estimation by the colorimetric method. In colorimetric method, how we can estimate it? So it gives a purple or blue color with anisaldehyde in presence of sulfuric acid, like a Lieberman-Bouchard reagent. In the anisaldehyde with the sulfuric acid, it gives a blue color. This forms the basis of estimation because we get a color reaction. The intensity of color developed is proportional to the amount of glycyrrhetinic acid which is measured at 556 nanometer. So here we have to measure the intensity of color which is developed, and it is directly proportional, or it is proportional to the amount of glycyrrhetinic acid, and it should be measured at 556 nanometers. So it is a colorimetric method for the estimation of glycyrrhetinic acid. Now we move on a rutin. Rutin is the another chemical constituent. Rutin is a most flavonoid glycoside, and it is derived from the citrus fruits. So here we can see that rutin is a citrus flavonoid glycoside found in many plants, including a buckwheat, Phagopyrum esculentum, Ruta graveolens, and the citrus fruits. So rutin is derived from various biological sources, but these two are the main biological source for the rutin. One is the Ruta graveolens, and second one is a buckwheat. Buckwheat contain a highest amount of rutin as compared to the any other plant. Rutins occurs as a yellow crystalline powder. It is soluble in alkali but only slightly soluble in water. The main use of rutin is it is mainly used in a capillary fragility factor. It is one of the most important drug which should be used in a capillary fragility factor. Also, it is used as a vitamin P. Rutin is a flavonoid glycosides. When rutin undergoes the hydrolysis, it produces the aglycone. It is a quercetin and two sugar molecule like a glucose and the rhamnose. So it is a basic introduction of the rutin. Now we move on the isolation of the rutin. Take 20 gram of coarse drug powder, which is obtained from buckwheat or Ruta graveolens, and extract in a Soxhlet apparatus with 250 ml 80% ethanol or up to complete extraction. After the extraction with the ethanol, we have to filter the ethanolic extract and mix it with 25 ml water, and again extract with petroleum ether and chloroform. After extracting with the petroleum ether and chloroform, we have to collect the aqueous layer and keep in cold for 72 hours. Here we have to remember that we are also extracting with the petroleum ether and chloroform, but we should not collect the petroleum ether and chloroform layer. We have to collect the aqueous layer. Okay, it will contains the rutin and another chemical constituent, whatever the present, they will remove out with the petroleum ether and chloroform extract. So we have to concentrate on the aqueous layer. Then after keeping for 72 hours, we will get the yellow precipitates of the rutin. These precipitates are separate out. Wash it with chloroform, ethyl acetate, and ethanol. The ratio should be 50 is to 25 is to 25. Wash precipitates are dissolved in hot methanol and filter it. The filtrate is evaporated to dryness to get a yellow powder of Rutin. Here we are dissolving in methanol, so we will get the pure product of the Rutin, and yellow powder of Rutin finally we will get. So the color of Rutin is a yellow crystalline powder. Now identification and analysis of the Rutin. So identify by the chemical test. It is a flavonoid glycoside, and all we know that flavonoid glycoside generally gives a Synoda test positive. So one of the test is a Synoda test. You can see over here with FeCl3 it gives dark green color. With lead acetate it gives orange yellow precipitates. So these are the three chemical tests. But one of the most important is Synoda test. You must write down Synoda test in exam, and in the Synoda test we get the crimson red color appears. So it is the positive symbol of the Synoda test. How the analysis? We can analyze by the TLC method. In the TLC method, stationary phase silica gel G, mobile phase should be a here 10% aqueous sodium chloride solution. It is a different mobile phase as compared to the another drug. Now sample preparation, how to prepare the sample. 1 milligram per ml solution of Rutin should be prepared in methanol. Then standard drug, we have to take a Rutin to compare with our extracted Rutin. So RF value we will get is a 0.43, and the yellow spot we will get. So it is a TLC method. So thank you very much. Thank you.